Hi, this is Bharat, Assistant Professor, Department of Electrical Electronics Engineering, SNS College of Technology, Coimbatore. We have been seeing the lecture series for the course Measurements and Instrumentation Engineering. So, our previous topic of discussion was unit number 3, that is electrical and electronic measurement. The topic 1, what we discussed previous was moving coil instruments, or otherwise it's called as permanent magnet moving coil instrument, which is PMMC instruments. The next topic is going to today, we are going to see about the moving ion instruments. So, come let's get into the video of moving ion instruments. What are moving ion instrument? What is the need for moving ion instrument? As we saw in the previous video, we saw about the moving coil instrument, which is mainly used for measurement of analog, and the devices which is used is analog devices and used for DC measurement. So we have some disadvantages in the case of PMMC instrument that could be overcome in PMI instrument. It works for both AC and DC, and it is simple and construction. It is also an analog type of measurement used for the basics of all the things. So the instrument classification we have seen already. This is a small mind map what we have seen in the previous case. Analog type of instruments works for AC and DC in this robust and industrial use. So comparison between analog instruments and digital instruments is also shown over here. The various advantages makes it easier, simpler, cost-wise, construction. Everything is simple. So we go for MI measurements in many of the cases in industry and academic purpose. So we could see the construction of an MI instrument. So what are this MI instrument all about? The following are the constructional parts of an MI instrument. We have a chamber-like structure, which is called as which has a coil winding. We have a controlling weight for the pointer in the opposite part, which provides some controlling action. Moving ion vane is there, circular part, and the balance weight is there for the pointer, and air chamber is there to provide the damping. So this is the construction of the MI instrument. So you have coils on the top and bottom, moving vane, fixed vane, control weight, coil winding, balanced weight, and air chamber. So these are the various parts of the MI instruments. So what is about the working of these instruments? So working principle is very simple, as like the previous case of moving coil instruments. So in the case of moving ion instruments, there are two classifications. One is attraction type and second one is repulsion type. So attraction type is an iron vane attached into the coil. Second repulsion then is two vanes repel each other. So here you have one vane moving ion vane. There you'll have two vanes, which is first case is attraction. The name itself says attraction type. It acts as a magnet which attracts the coil, and repulsion type two vanes will be there. We have a repelling in nature for magnet. So electromagnetic force is directly proportional to square of the current. So deflection torque is produced based on the what is the square of the amount passing through the coil. So once the current passes through the coil, in the square of the amount, there will be an attraction to the moving vane, moving ion. That moving ion moves towards inside the coil. Once it moves inside the coil, the air chamber pressure comes down. The pointer tries to move in the right direction depending upon the amount of current. That is the square of current, square law. So force is directly proportional to I square. So there will be a movement. So the torque equation here becomes T torque developed is directly proportional to I square, and the controlling torque is K into theta provided by the air friction damping. And square law, the square law is stated theta is directly proportional to I square, that is deflection is proportional to the square of the current. So sensitivity depends upon d theta by di. So what are the various applications which are used here for MI instruments? So we have seen about the construction and working of MI instruments, and also we have seen the various characteristics of various types of the MI instrument, that is attraction and repulsion type. So it is applied in different parts of industries for measurement of mainly AC voltage values, current values, high voltage ranges, and the robust construction. So MI meters are very accurate. AC current measurement, not accurate up to digital, but it is still accurate. High current ranges, DC measurement capability, industry applications are many industry applications are there for uh, MI instruments. So this image shows the construction of an MI instrument. So practical setup, voltmeter, you have a series connection, ammeter is always in parallel connection. Measurement will select the appropriate range depending upon where and when required and it is used. And there are various industrial applications and power system applications. So as a summary about all these things, we have seen the key concept of what is MI instruments, moving ion instruments. They include attraction type and repulsion type. It based on the work law square law of deflection, that is theta is directly proportional to I square. AC/DC dual capability is there for these instruments. So what are the various advantages? Simple design, low cost, robust construction, AC/DC capability, everything is there for MI instruments. So limitations, we have some nonlinear scaling, lower accuracy compared to digital measurements, power consumption is there, frequency effects is there. In spite of all these things, the cost is very less compared to digital. So many of the time we go for unlike precise equipments, we go for this MI instruments. Okay, thank you. So we'll meet you in the next video.